Hello, good morning friends. In today's lecture we'll see correlation. So the relation between two signal it is known as correlations, or we can say the comparison between two signal it is known as correlations. Now where we can use the correlations? So the applications where we need to compare a signal with respect to the another signal to determine the similarity between these signals, we can use the correlations, or by relating these two signals we can have the additional information. Okay, so the correlations we can use for the timing purpose, for a distance recovery purpose. For example, we can use in radar system, we can use in sonar system, we can use in CDMA receiver, also we can use in ultrasound system. Okay, now next is type of correlations. So we have two types of correlations. One is known as auto correlations and the second is known as cross correlations. So we'll see auto correlation. So the auto correlation is what? When we compare two signals and these signals are generated by using the same source, then it is known as auto correlations. So we have the equation here. RXS, let me take the pointer options so it will be more clear to you. Okay, so the X and X indicates it is relation between the same R XX of L. This L is known as shift parameter, or it is also known as R parameter. This index L is known as shift or lag parameter. Now when you see this equation is similar to that of the convolution between these two signals, but in convolutions here we will be using circular time shifting property over period n, and here just we are using the time shifting property for the lag parameter. Whatever the value of lag parameter will be having, for that we will be using the time shifting property. And when you calculate here the value of L is positive, when the value of L is negative, we will be having these equations, and both the values are symmetric. So Rx of L is equals to Rx of minus L. So this auto correlation function is also known as even function, or it is also known as a symmetric function, and the maximum value of auto correlations will be having at L is equals to 0. Okay, when the index L parameter is equals to 0, that time we will be having the maximum value. Now we will see a question on auto correlations. So find auto correlations of a given signal x of n 2, 2, 1, 1. So here arrow is not mentioned, so by default this is my 0th position. So the number of samples in the output sequence is equals to what? So the sequence of x of n, samples of x of n, again auto correlation, relation between same signal. So we will be having x of n twice. So x of n samples is equal to 4, again x of n samples is equal to 4 minus 1, so that is equals to the 7 samples. So number of samples in the output sequence is equals to the 7. Now the range of number of samples we have got, that is equals to 7. Now where is the positions of arrow? Now before arrow there is 0 samples, and after arrow there is 3 samples. So the positions of arrow will be at a sample. After that sample will be having what samples? Will be having the 3 samples. We will see. So this is my sequence, relation between same x and x. Now here I can write the sequence of x of n. Here also I can write the sequence of x of n and will multiply. So I have written the sequence of x of n, again sequence of x of n, then you multiply 2 into 2, 2 into 2, 2 into 1, 2 into 1, and like that. So we'll be having this answer. Now we have to add this diagonal. So here it is 2, then here it is 2 2, 4 2 1, 4 4 1 1, 4 2 1, 2 2 2. Now how to read the value? So when auto correlations, we are moving from top to the bottom in this direction. As we can see, I have shown the direction here. This is the direction. We'll be moving from top to the bottom. So we have the answer as Rx of k. Here I have considered k as my index. So we will be having 2, 4, 7, 10, 7, 4, 2, as I have mentioned. So the positions of arrow will be at a point. After that we will be having what samples? We will be having 3 samples. So positions of arrow will be at 10. Okay, after 10 we'll be having 3 samples, and as I mentioned earlier, it is what? It is symmetric. So the autocorrelation is always known as a symmetric function, or it is also known as a even function. Now we'll see the cross correlation. Now when we compare two signals and these signals are generated by using a different source, then it is known as cross correlation. So as you can see here, x and y. X is my first signal, y is my second signal. We have to find relation. L is my index parameter, index lag parameter or shift parameter. So the equation it will remain same. Instead of here x, here will be having y. So as we can see here, r x y of L is equals to r y x of minus L. So it is what? It is the folded version around what? Around L is equals to 0. Now we'll see the cross correlation. So the method it will remain same as that of the autocorrelations. Only what? Only we have to move from lower to the higher positions. While writing the number of samples in the output sequence, we have to move from what? We have to move from bottom to the top. Now we'll see here. Here before arrow there is 0 samples, before arrow there is 0 samples. Okay, so the positions of arrow is what? The positions of arrow will be at a point before arrow. After arrow will be having what samples? After arrow will be having here before arrow there is 0, here before arrow there is 0. So after arrow there are 3, before arrow there is 0. So 3 plus 0, so we will be having only 3. This is a shortcut method to find the position of arrow. Before this, after this arrow there are 3 samples, so it will be 3. Now here before arrow there is a 0 samples, so 3 plus 0, so we will be having 3. So after arrow we will be having 3 samples. In the output sequence, after arrow we will be having what samples? We will be having 3 samples, and the number of samples is what? 4 plus 4, you can see 4 plus 4 minus 1, so it is equals to 7 samples. Number of samples is what? Number of samples is 7. So this is the formula, and the method it will remain same. You put the equations of x of n here, you put the equations of y of n here, then you multiply, will be getting answer. You take the diagonal addition, but we have to move from what? We have to read the value from bottom to the top, so we'll be having direction like this. Now you write the sequence as 1 here, 4 6 6 5 2 1. Now the positions of arrow will be at a point. After that arrow will be having 3 samples, so the arrow will be at what? Arrow will be at 6, and after this arrow will be having 3 samples. Now here we can see a tabular method, so we need to draw a table and we have to solve. So see, now first we will be finding the positions of arrow. After this we are having here 2 samples, and before here we are having 0 samples. So after arrow in the output sequence will be having what? Will be having 2 samples. Now the number of samples in the output sequence, so is equals to, here it is 3 samples and here it is 5 samples, so 3 plus 5 8 minus 1 7. So in the output sequence will be having the 7 samples. That means the range of L, it is going to vary from 7 samples are there, going to vary from -4 to 2, because after arrow will be having 2 samples, so the end position is 2, and before is what? Will be having -4 samples. So -4 -3 -2 -1 0 1 2 will be having 7 samples. Okay, so this is the formula. Range of L we have got -4 to 2. Now you draw a table. Okay, so the range of n, here I have taken -4 to 6 because 6 we required for the performing the operation. Now range of x of n, sequence of x of n, you write for 0 it is 1 2 4, so 0 it is 1, for 1 it is 2, and for 2 it is 4. Also you write the equation of y of n. so varying from 0 to 4. Okay, these two steps we have to take from the input x of n and y of n. Now here we need to put the value of L. So the value of n is going to ranges from -4 to 2. So if I put the -4, the equation becomes y of n plus 4. So as we have known, the n plus 4 means what? N plus 4 is equals to 0. So n is equals to -4. So initially the sequence is varying from 0 to 4. After taking -4, so the sequence is going to vary from -4 to 0. So it is shifted -4 to 0. So as we can see, it is the advanced signal. Okay, now n plus 3, so n is equals to -3, so signal is going to vary from -3 to 1. Again from n plus 2, signal is going to vary from -2 to 2. n plus 1, signal is going to vary from -1 to 3. And when L is equals to 0, the equation it is going to same with y of n. When I put n is equals to 1, n minus 1 is equals to 0, n is equals to 1, so the equation is going to vary from 1 to 5, and for 2 it is going to vary from 2 to 6. Then you multiply. See here, x of n, it is going to multiply with this equation. So here the amplitude is equals to 0, so the multiplication is going to take place for this 1 into 1. So at -4 we will be having the answer as 1. Then from this equation to this equation, okay, here the multiplication is become 0, only it is going to take place for 1 into 1 plus 2 into 1, so it is equals to 3. Then this equation and this equation, so the multiplication going to take place for 1 into 1, 2 into 1, 4 into 1, again from here and here. So the multiplication going to take place for 1, here 2 into 1, 4 into 1, and here it is 0. Again the multiplication is going to take place for, here it is 1 into 0, 2 into 1, 4 into 1, and here also it is equals 0. And the last, the multiplication is going to take place only for 4 into 1, rest all it is equals to 0. And we'll be having this answer, Rxy of L is equals to 313777764, and the positions of arrow will be at 7. After 7 we'll be having 2 samples. So in this way we have to solve. Next, so again 2 sequences is given, we have to find the correlations. So here correlations what type? X and Y is given, so it is cross correlation. Now here, so first we'll be finding the number of samples. So here 1 2 3 4 5, here 1 2 3 4 5, so 5 plus 5 is 10 minus 1 it is 9. So 5 plus 5 10 minus 1 it is equals to 9. So number of samples in the output sequence is equals to 9, and the positions of arrow. After these 4 samples are there, and before these 2 samples are there. So the number of samples after arrow is equals to 6. So the range of L, it is going to vary from, okay, going to vary from what to what. So after we have the number that is equals to 6, number of samples is equals to 9. So to have a 9 samples, here we require -2, okay, -2 to 0. So when you count -2 to 0, it becomes a 9 samples. So I have written -2 to 6. Okay, so you just write the range of n, you write the x of n to x of n, y of n as it is mentioned. Then y of n plus 2, you shift the equation. So the range, it is ranging from -4 to 0. Y of n plus 1 ranging from -3 to 1, y of n minus 1, y of n minus 2, y of n minus 3, y of n minus 4, y of n minus 5, and y of n minus 6. Okay, now you multiply. So multiplication is going to take place for the first this sequence, okay, from here to here. So here multiplication is going to valid only for this point, rest all is equals to 0. So 0 into 0.5, so it becomes 0. Then the next one is what? The multiplication between these two sequence. So here 0 into 1 it becomes 0, 1 into 0.5 it becomes 0.5. Then again from this equation to this equation, 0 into 1, 1 into 2, minus 2 into 1, 3 into 0.5, and then so on. After that we'll be having answer as Rxy of L is equals to 0.5, 0, 1.5, minus 2, 0.5, minus 6, minus 2.5, minus 2. Now positions of arrow, after the arrow will be having what samples? Will be having 6 samples. So the positions of arrow will be at 0, and after 0 will be having these 6 samples. Okay, in this way we can solve the autocorrelation and cross correlation. Now some properties we have to see regarding autocorrelation and cross correlation sequence. So if the signal are scaled, the shape of the correlation it will remain same, it does not change, only the amplitude gets changed. Now we have to find the normalized autocorrelation and cross correlation of sequence, and this normalized value it is ranging from -1 to 1. Normalized what? Whatever the value we are having from cross correlation or autocorrelation divided by its maximum value. So the normalized autocorrelation, so the maximum value, as we have known, the maximum value for autocorrelation it is at 0. So that's why Rxx of 0, and maximum value for cross correlation is under root of Rxx of 0 into Ryy of 0. As you can see here, under root of Rxx of 0, Ryy of 0. So in this way we can solve the autocorrelation and cross correlation. Thank you very much.